Last time we defined sums and direct sums of subspaces. Today we prove two useful tests. Because apparently definitions are not allowed to just sit there peacefully. The goal is simple. Turn the phrase uniquely written into something we can actually check without staring into the algebraic void. First theorem. For several subspaces, being a direct sum is equivalent to two conditions. Condition A says the subspaces actually add up to the whole space V. Condition B says that the only way to make the zero vector from one piece in each subspace is to choose every piece to be zero. Together, those two conditions are exactly what direct sum means. Notice how 0, the least exciting vector, is somehow doing quality control. Now the proof. We will not chant every symbol like a sleep-deprived notation cult. We will track the actual idea. One direction is almost rude. If V is already a direct sum, then it is certainly a sum. And 0 has the representation 0 plus all the other zeros. Since direct sum means representations are unique, any other way to write 0 must be the same boring all zero way. For the other direction, assume A and B. Condition A gives at least one representation of every vector. Existence. Handled. Thank you. Condition A. Finally doing your job. To prove uniqueness, suppose the same vector has two representations. Subtract one representation from the other. The vector disappears, leaving 0 written as a sum of pieces from the same subspaces. Condition B now says every difference must be 0. So the two representations were not two different representations after all. Let us apply the theorem before it starts looking like abstract furniture. Take the three coordinate axes in R3. Every vector A, B, C splits into its x part, its y part, and its z part. For the zero test, if the sum of one vector from each axis is 0, then each coordinate must be 0. No coordinate can hide in another axis. Very inconsiderate of ambiguity. So by theorem A, R3 is the direct sum of the three coordinate axes. The next theorem is the two subspace version, and it is much easier to use. Mathematics occasionally remembers that we are mortal. For two subspaces U and W, V is their direct sum exactly when two things happen. First, U plus W is all of V. Second, their intersection contains only the zero vector. In other words, the only vector shared by both subspaces is the one vector that was already doomed to belong to everything. Now let us prove the two subspace test. This proof is short, which is suspicious, but legal. Suppose first that V is U direct sum W. Then V is certainly U plus W. The real issue is the intersection. If V sits in both U and W, then 0 equals V plus negative V. That writes 0 as a piece from U plus a piece from W. But direct sum gives a unique representation of 0. So V must be 0. The intersection is trivial. Ambiguity has been evicted. Conversely, suppose V equals U plus W and the intersection is only 0. We use theorem A, so we only have to test how 0 can be written. If 0 equals U plus W, then U equals negative W. Since U is in U and negative W is in W, U lies in the intersection. The intersection contains only 0. So U is 0. Then W is also 0. The 0 representation is unique. And theorem A finishes the job. Now an application. This is the part where the theorem stops being wall decoration. Let U be the x-axis in R2, and let W be the diagonal line y equals x. Together they span the whole plane. For instance, 1, 3 equals negative 2, 0 plus 3, 3. Their only shared vector is the zero vector. A vector on both lines must be both horizontal and diagonal, which leaves it with the thrilling career option of being zero. So by Theorem B, the plane is the direct sum of the x-axis and the diagonal line. So the moral is this. Direct sum means existence plus uniqueness. The theorems give us two ways to check uniqueness without begging the notation for mercy. For many subspaces, check that the sum is the whole space, and that zero has only the all-zero decomposition. For two subspaces, the zero test simplifies to checking that the intersection is just the zero vector. Next time, we can start using these tests without reproving them every 5 minutes. A rare mercy in the bureaucracy of mathematics.